Hi, everybody. My name is Roberto Hernandez, and I work for Inferno Red Technology, one of the sponsors for the event today. And I'm going to talk to you about automating your infrastructure with Terraform. I guess a bit more about me before we dive into that. So I'm a Microsoft MVP for C#, way back when in the day, 2007, 2008, all the way up to 2014. And I have been working with that technology scene forever, and working with continuous integration, continuous development, with just something that is very keen to the topic I'm going to be speaking up today, Terraform, in one way or another. So let's go ahead and get started. I'll just start flicking through this first slides. And like most of my presentations, if you've ever attended one, my presentations are code heavy. So we are going to be diving into some demos and looking at how the code works. I am dependent on the Azure cloud today, so a lot of those demos are depending on my bandwidth and the responsiveness of the cloud. I'll just add that caveat there and fair warning. So what is it that we're going to cover today? So even though this is not a presentation that I want to go deep on what is DevOps and why is it important for you, I do want you to know what the term means. So that's one thing that I'm going to cover in as briefly as possible within this presentation. Also, I'm going to be talking about Terraform, which is a wonderful technology that allows us to build our infrastructure using constructs that are akin to the DevOps philosophy. So we're going to basically build out our infrastructure using code that will go into a bit more detail later on how it is written and which tools are actually used to process that code into infrastructure. And of course, demos. So with that, let's dive right in. And again, not strictly a presentation about DevOps. The Terraform tool can be used by people who do not adopt the philosophy, but definitely the folks from HashiCorp, which are the main maintainers and supporters of this project, build this tool thinking about DevOps. So what is DevOps? DevOps is the combination of development and operations into a single unit to provide value to customers. What does that mean in general terms? In a specific development terms, we're talking about basically automating your infrastructure by writing code that represents it and making it part of your developer cycle. So if you have a continuous build that's running your automated tests against your code base, and is deploying your environment to an infrastructure, so does that infrastructure in the DevOps philosophy should be managed by code that represents it, be versioned, and you should be able to spin it up, take it down, spin new environments as fast as you can. So to circle back and just summarize all that, DevOps just brings the operation department, which in traditional models are apart from your development teams, into the fold, into projects that are practicing Agile, that believe in the DevOps philosophy, and making them part of the development cycle. So that infrastructure that gets deployed onto the, in our case today, the ones we're going to sample to the Azure cloud, are written in code, version, and deployed as regularly as your application is. Benefits, again, add value to the customers because we're receiving the changes as soon as possible in a repeatable way. So I guess that's it. If you guys want to know more about DevOps and other tools that comprise that can help you in your DevOps adventure, you can go to the Microsoft website I put on the bottom. That's definitely one of the resources that I would recommend if you want to start implementing and embracing the DevOps philosophy. So what is Terraform? Terraform is an open source tool. I did mention while I was going on what we're going to cover that it is managed by HashiCorp. And it's a tool that was written in Go. Now that it's important for if you're consuming the tool. And it's based on defining your infrastructure using a configuration language, sort of like what's on the right of my slide right now. And using that configuration language to represent our infrastructure that is deployed continuously to the cloud through that toolset. And the toolset's really simple. This actually goes a bit more into my next slide, which is defining the toolset. But the toolset for Terraform is actually just an executable On my machine right now, I'm running on a Mac, but this is really a cross-platform. If you're running on a PC, you could run it on Windows, or you could run it using the Windows subsystem library. So if I just go ahead and click version here for something simple, you will see that I have the version 1.08 installed on my machine for AMD 64. It says it's out of date. Obviously, not good to update something right before a demo, so I won't be touching that. But back to my slides. So the toolset, again, very simple. It's just a Terraform executable. And we're going to be writing configuration files that represent the infrastructure that we're going to deploy. Now, in that configuration language, we will use terminology such as modules, things that are common to other programming languages like variables, expressions, etc. And we're going to also talk about things like provisioning your infrastructure and managing the state. Now, these are going to be part of the demo, so I won't go too much into detail, but to give it a once over, modules are just the ability to reuse those configuration files that you have written for your infrastructure. For example, if you're deploying an array of web servers, one module might represent a web server. And then you could basically just say, deploy me 3 flavors of this module, which are 3 different web servers being deployed to your infrastructure environment. Provisioning is basically the means to, if you're deploying, again, 3 web servers, what's going to be deployed on top of them? Are they going to be using, and I'm going to be using Linux terminologies here, are they going to be hosting Apache web servers? Are they going to hold hosting Nginx? Or is it going to be something as simple as perhaps running .NET runtime and deploying something using kernel? A state is one of the most important concepts when working with Terraform. It's basically a representation of how your environment is defined at a certain point. So if I deploy my environment to Azure, all the information on how that environment was built, which resources were built, are saved in state. And that is important because if you see on the life cycle on the left, when I write a configuration file that defines my infrastructure, I tell the Terraform tool to write a plan on how to basically create that. Then I apply, which basically creates that infrastructure based on the plan. But what happens after that? What if I need to make a modification? So basically I modify, should have put modify there on that last bubble on the bottom, but I modify the configuration files that I've already written. And what happens now? A plan is written to apply those modifications, but that plan is based on the state. So if I created 2 web servers and now my modification says that I need to deploy 3, my plan is going to say that 2 instances are not going to be touched, so remain unmodified, and 1 instance is going to be added through the creation process. And we'll see a bit more of that in a sec. So development cycle for working with Terraform and building infrastructure, writing your configuration files, use those configuration files to build up a plan, apply those plan into your target infrastructure, and modify and rinse and repeat as much as necessary. The apply process is the only one that's target specific. The presentation today is going to be based on Azure, so we're going to be using the Azure RM provider in order to do that work. Let me show you a bit of the websites where all this information is actually contained so that you can have those resources available for you in the future. So if I recall, so again, Terraform documentation, pretty thorough, pretty extensive. In fact, if I'm going to give a shout out to the work that's been done by HashiCorp with this open source platform, is that it's very well documented and extensive. Now, the Terraform configuration language has, like every other operation, no, I don't want to say programming language because it's really configuration, but it has basically providers, data sources, resources, variables, etc., which we are going to go into a bit more detail. But like I mentioned before, it has providers that define how those configuration gets applied. And here's where it starts to get fun, because all the cloud platforms that we love and embrace and have to use every day probably on our everyday work, like AWS, Azure, Oracle, or Google Cloud, Kubernetes, are covered as providers. There's a rich library of providers that you probably won't have to extend, But if you want to, there's definitely the capabilities to do so. This is an open registry. As long as you provide enough information, sign your deliverables, they'll definitely host it in the registry for you and you'll be able to use it. And going back to my slide, the previous one in this case, because I do want you to look at this a bit more before we dive into the demo. So this is a configuration file from top to bottom, and everything that's needed to do any work in Terraform is included. In fact, there's probably a bit too much. So here we have the Terraform element, which is just for configuration of how the CLI tool is going to work and what is going to be its requirements. So similar to what you would call a dependency management file, here you would say, I am going to be using the Azure RM, but I'm not letting it to change in saying which version I'm going to need. I'm going to say I need a version that's greater than 2.65. So I'm locking in which version I need in order to execute this configuration file. Also, I'm just defining, this is just to configure a bit more of the features. We are going to be using this later in order to configure where to manage the state. So in fact, what you'll notice in the files that I'll be showcasing is that I'm really not going to be using the Terraform element. I am going to leave a lot of things to chance. It's a demo, but I am going to be having the provider elements and more configuration. Now, in this scenario, it's only a single resource, and resources are the translate to infrastructure in your deployment environments. So in this scenario, the resource that is getting built, it's a resource group. So the basic building block of the Azure cloud. And this resource group is going to be built on the West US2 environment, and it's going to be called my TF resource group. So I guess enough talking in that sense. Let's just do a basic demo on how to get one going. And all this code, I wrote a bunch of demos yesterday, tested them out. Hopefully they work for us. But all this is going to be available on GitHub. I will make the slides available at some point and tweet out also the reference to the GitHub repository where all this is in. So again, I'm running the terminal inside VS Code. VS Code makes everything better. And my first demo is basically going to be a hello Terraform. And I'm not really going to write the code. I'm just going to showcase it like I did a second ago. So what we have now, it's Terraform. And in this case, we're not going out to the cloud. This is probably one of the fastest demos that's going to run in today's presentation. So what we have is the Terraform, the required providers, Docker. And we're actually not going to be deploying to a remote Docker environment. We're actually going to be deploying to my machine. But it's a very good test case on the different elements that are necessary. So now that I expressed which provider I wanted, which version, I said that I am going to use Docker. And the first resource that I defined, so what do I want? I want the Docker image Nginx to be downloaded to my Docker current repository. And just to make sure that we can showcase that, I'm going to go Docker images. And I do have an image there, just a SQL Server image, but I don't have the Nginx image itself. The second element, again, resource, Docker container type in this case. And this is a general name. It says Nginx on it. Could have been anything. Could have been, I don't know, Mac. But Docker container, name Mac. And I'm saying use the image that we downloaded, name it tutorial, and map the ports 80 to the external port 800. Now, back to the life cycle. Most of my projects, I actually have a file called build that manages the life cycle for me. I'm not going to do that for this one. I'm actually going to run through the paces, but this is what it looks like. And this pretty much matches what was on the slide. I mean, we write our configuration file. That is what we have on the main.tf. We initialize, could be done at the same time. We build out a plan and apply it to the cloud. My apologies. So let's give it a try. Oh, and for all you Docker fans out there, basically what we're going to accomplish is what happens in this line of code. So we're going to download the machine, we're going to run it, map a port, and call it tutorial. That's all that we're going to do. So I'm just going to go ahead and do a Terraform init, which should, oops, wrong directory. And I want you to notice what happened to the folder structure. So a log file was created. The reason why the log file was created is because the state is being managed locally. So this is the file that needs to be accessible and readable in order for the process to run. Also, the Terraform folder was created, which basically holds the providers that were defined in my file. In this case, the Docker repository, I have to span a bit more to see the name, but there it is. Don't know how to pronounce that name, /Docker 2.13.0. So that happens during the initialization phase. Now, if I wanted to build a plan, the way you normally do it is just specify the name of the name of a file for the plan to be created. Now, if I do this, a plan is generated, and let's dive a bit into what gets displayed here on the console. It's important to get familiarized with the output just because all of this is probably going to be running on your build server. And build server is probably an outdated term at this term, but if you're running your GitHub Actions, if you're running your code in Azure DevOps, this is going to be running on your in your build server to actually push this information out to the cloud. So what we have here is a list color-coded to tell us which resources are going to get built. The Nginx image is going to be downloaded. The Docker image is then is going to be run. So 2 resources to be added, 0 to change, 0 to destroy. Now, in order to run that plan and apply it, all you have to do, and again, this is what's happening on my build script, run.plan. There's my file run.plan. So it happened really quick. Let's see if there were any things that clues that the process happened successfully. So if I do Docker images, there is the Nginx image that was downloaded. If I do Docker processes, there is a Docker process running that maps the internal port 80 to the 800 on tutorial. So I do have the browser open right here. So let's go ahead and test that anything happened. And there is the Nginx server that's running on that Docker instance. Now, the customization on this part, the provisioning was really simple. I mean, it was just downloading a Docker image. Later on, we'll do a more complex environment with a virtual machine where you actually want to run code to initialize the application. So I think that's it for actually this demo. Let me, just for completing the full cycle, like what do I need to do if I wanted to destroy this environment? So one of the things that I can do is basically Terraform Destroy. And Terraform Destroy should basically look at the state. And it's asking me if I want to do this or not. If you look at, I also have this automated in most of the environments that I do. I have not the cleanup, sorry, the tear down script. And if you notice, I do the auto approve option on most of the time. So I'm just gonna, not for this one, but I'll just type yes. And there it is. Now, let's see what happened now. Docker images, the image is gone. Docker processes, all, just to make sure it's not even stopped, it's gone. I don't have anything running right now. So pretty simple demo, but it lets me walk through the different parts of the configuration language, which is configure Terraform and how you want it to run, specify your providers that you're going to be using. And in this scenario, we specified a specific version of a provider. That's not necessarily the case all the time that you're writing Terraform script. And define my infrastructure, my resources, in resource blocks, and in this case, those resource block, Docker image Nginx, Docker container Nginx. Now, before I move on, I'll go back to my browser, There is, and it's definitely a valid question, going back to the repository of providers. So where is the information that's actually going to tell me what I need to write in those providers? So I'm going to click through to the Azure one just to prove that every single one of these repositories has actually a very extensive documentation attached to it. So like if I wanted to do something like create an app service, for those of you that are not fully versed in Azure terminology, these are basically a website, and they used to be called websites, but now they're called Azure App Services. So if I wanted to build an Azure App Service, here's the documentation, and for example, a configuration file that I could use to start my work. There are also configuration files that are part of the Microsoft documentation. So if I look here at, let's see. So there is extensive documentation on how to use Terraform on Azure and the best practices around it. That's also going to be part of the resources listed on the slide. But for now, I guess let's kill that. We know then how to get information on the providers and what resources they provide. I am using Visual Studio Code, and that helps me out in the sense that sometimes, I want to say, sometimes it gives me IntelliSense. Maybe we'll test that again when we're working with the Azure Rm provider. That is definitely a more thorough, written professionally one. So, first demo done. Let's go back to my slides for a second here. So I already ran through this a bit, but let's go quick through it again. The configuration language. So it is a language that is based on convention. So the way you structure your files matters. Usually what you'll find, and I'll showcase it when we look at the Visual Studio Code again, is that all files that have a .tf extension on a certain directory are part of what's going to be parsed by the Terraform CLI and used to build infrastructure. So every single resource block is going to be a piece of your infrastructure, and those resource blocks are defined in providers that are hosted in the Terraform registry. Now, I want to say it's 100% of the time, you're going to want to modify your deployment based on what the environment you're targeting. Very common need, right, is you're deploying to a development, staging, and production environment, and you don't want to have different configuration files for each one of those. So what happens? You have different variables that affect how those configuration files behave. So this is a very important concept within the configuration language, and we're definitely going to demo it. Modules, we're going to go into a bit deeper later, but those are the building blocks that allow you to reduce code within your environment. And like any language, it has expressions that you're allowed to use. If you're familiar with the Elvis operator, so the famous IIFs for Visual Basic, definitely are things that are supported within the configuration language. And there are also a ton of functions built into the configuration language that can be used. And like a lot of things, singing praise to the folks at HashiCorp, if we look at their documentation, there's extensive documentation on the built-in functions, numeric, string, collection, etc., and the expressions that are supported. So with that being said, let's go ahead and do a first demo that now uses variables in order to create a more flexible environment. So we have this, and this is actually a working directory. Like I said, what you're commonly going to find when you're working with TF is that everything starts from a main.tf, that's the convention. And usually, and you'll see this is a very compact file, what we have is the provider, which in this case is Azure Rm, and resource manager. In this case, we're going to have the resource, which is what we want to deploy. And this one's really simple. Let's just say rg demo east US and the east US2 location. So let me go into that directory. And I could actually build this. Should be really quick. It's just a resource group. Famous last words, of course. But it's doing everything that we actually discussed before. So it is initializing the environment to download the providers. It's creating a plan that run that plan, and it's actually applying that plan out to the Azure cloud. Why can it access the Azure cloud? That's actually something that I haven't said. So the Azure CLI, so everything that's actually being used by the Terraform provider is dependent on the Azure CLI. Again, Azure CLI is a cross-platform tool, so Windows, Linux, Mac, it'll work on. And in my case, I have version 2.28.0. Again, needs some updates, but doesn't really matter at this point. And I am connected. If I do, let's see, account show, I am connected to this Azure subscription that I get by my employers. I'm going to bust up the term. I'm going to use the old one, the BizSpark subscription. I get 50 free Azure credits a month. Let's see. So this ran. It says that it completed. It says that it created the resource group. It gives me a nice graphical view of how that resource were created. And, well, talking about graphical views, if you're interested in that, you could actually get a sense of what the tool is doing, build a graphical view of what is going on. I've seen some folks actually embed this into their build artifact so they can track down what is really going on every time I deploy my Terraform environment. But back to Azure. And there it is. So again, it was just a simple resource, not very different from that first demo. So I'm just going to tear that down and let's make it use variables. So I can actually start writing code while that actually gets destroyed. So I'm just going to go to that main.tf file and not save it yet, but I could define variables inline here. So let's say variable, let's give it a name. Let's call it prefix, which is pretty common when working with environments that all your resources share a common prefix. Let's say this is a string and add a description for it. Now, if I don't add the description, what's going to happen if I execute the code is that it's going to ask me for that prefix. And it's not going to really be intuitive. So if I try to execute, let's go back to that init or build. Yeah, so it's going to go enter a value, which is not really something we would like. Let's just kill that. So description, and let's just go ahead and do something like prefix to be added to all Azure resources, or to all resources. Don't need to be specific. Now what happens now, if I hit build, I get a more visual explanation on what is actually required. Let's kill that again, because in reality, when defining variables, and this is the conventions on how to build your code base for Terraform, you are encouraged to have a variables file. So everything that I wrote in the main.tf, I'm just going to pick up, saved, add here, variable your location, type equals string again, description, location of resources. Sure. So aside from the indenting problem, that should work. Now I have two variables, and all files with a TF extension are going to get picked up, so I should be okay. Now my main file, I'm going to start doing some action with that. If I wanted to reference one of those variables, just bar.location should do the trick there. But in this scenario, it's a bit more complex. I want to replace demo with that prefix. So what happens is I can do some string interpolation and go bar.prefix. Now, there are many ways to provide values to those variables. We already saw that we can actually provide them inline, but that's definitely not how you would want your web server to behave, your build server, sorry. So in this scenario, what I'm going to do is, which is what I would call the advanced version of providing variables. Again, you can inline the values in your TF files. You could provide them manually, which is probably not an option, but if you want, the usual case is you provide them through environment variables. So in this case, prefix, and for this, probably NovaCodeCamp does the work. And let's create also a location. Let's say this is going to be deployed to East US 2. Now, I want you to notice that on my build file, I'm actually loading those environment values. So now I'm not going to see that screen that's actually asking me for those variables. It should just work or provide me an error for whatever I did wrong. Let's see what happens. Again, just a resource group, so it should be really quick. There we go. It did the location as expected. It did the prefix as expected. And it's taking a little bit of time to deploy to Azure. And let's go back here. Yeah, I don't know if Azure has been throttling me since I've been hitting them hard since I was prepping this presentation yesterday and running through them, but I've seen this a lot. I know the resource is there, and there it is, but it takes a bit of time to actually be visualized in their portal. So I'm just going to go ahead and destroy it just to be clean. Tear down. And apparently I don't have the source correct here. But might as well type it manually to save some time. And this was MVCC. Okay. That should work. And if it doesn't, I'll just clean up Azure manually. But let's go back to the, oh, actually, there it goes. It's destroying the resource. Let's go back to this slide so we can actually make some headway. So I guess in this scenario, we covered a bit of what was in the slide already, so variables. And the only thing that we didn't do that's on the slide, we did build input variables. Now, again, this is how we define an input variable by using the variable blocks and giving them a type. There are more complex types than the one I use. I use string. You could actually create arrays or lists. You can build arrays of objects or just objects. So there's a lot of things you can actually do with variables. Now, just to show you real quickly, the syntax for a local variable, let's say we didn't want to provide them, is to use the locals block. So I could have done something like something weird for now, but let's call it sub prefix. And let's just put sub. And here I could have done something like local sub prefix. The environment is doing some of its magic. If you notice, it's actually creating the references for the use of the variables. Not going to run this though. Really, we are going to be using local variables a bit more in the future. And there's also, from this slide, output variables. And those are built using the output block. So instead of a local output, will be what will be used, and this will be a specific variable. But we are, again, going to be using them a bit further on the other demos. So I want to say that we have covered this so far. We have seen the life cycle, so we know how to write, plan, and apply an infrastructure to Azure. And we have seen how variables help us add some flexibility to the environment we're building. Now, the second part that we're going to be talking about that adds flexibility to what we're building is modules. And modules are basically containers that allow us to reduce functionality when using Terraform itself. Sorry, have sort of a dry throat, trying to keep it from dying on me. So let's go ahead and do a module example. So even though this is going to be a simple demo, it falls within the category of something that's semi-realistic to what could actually happen. Let me kill this console just so we get good view. So here in this file, if you notice, we have a resource group being created at a specific prefix and location using a local variable here just for convenience purpose to translate the variables that are input in this file. So a resource group and a storage account is created. And again, this is a working demo. So if I went to the terminal and went to that directory, let me double check that my build file says source, which has been a gotcha for me lately. Okay, so it looks good. So I'm just going to go ahead and build it. This is going to run through its processes, build a resource group, build a storage. Storage are a bit more expensive resource, obviously, than a resource group. So this should take a little bit more time than the other ones. While that happens, though, as it's always good to see things work, let me go into the why of this demo, why the need for modules. So it's fine. We're building a storage account, a specific region, and a specific location. In this case, if I look at my environment file, I'm building it in ECUS 2 and using a prefix Nova Compact, Nova CodeCap CC. So what if I wanted to build multiple of these resources? What would I do? Well, is my best option really just doing a copy paste of this information right here and starting to copy? Probably not. Just in this demo, and again, this is a very compact demo, you can see that it gets unruly really fast. So let's check Azure real quick. Seems like that deployed. Here's the resource group, and if I look at the storage accounts, should be one coming up soon. See. Well, again, I think I've been abusing Azure and they're throttling me. But there it is. So let's destroy that to keep it clean. And let's go ahead and modify this so that we implement a module. So a module is just a folder that's going to have the same structure that the parent directory has. So it's going to have a main TF, a variable file, and other resources that could actually be needed. In this case, I'm just going to call this regional storage. And I'm going to add a main.tf. And in that main.tf, what I'm going to do is just copy the portions that are related to the resource group and the storage and add them to these files. I did not copy the provider over. When you're reducing functionality this way, the providers can only be defined in the top level module. So this seems correct. The variables now that are defined, I'm also going to move into that regional storage folder. And here we have a prefix and a location. Now this is going to change a bit how we're doing things. I'm just going to remove this from my environment. It's not really going to be needed. So let's say that now my objective was to build two different I should have taken this into that main file. And because the reason why I had those locals there, again, it just simplifies the demo itself. Because I don't have to change all this bar when I'm moving the code from one location to another. So I'm using the locals just to do one task quickly, which is assign the prefix of one place and location. So variables are defined at the module regional storage. And now on the main.tf, let's consume that module by doing the following. Module, And you can give it any name you like. Really, this name is just for reference. In fact, let's just keep it short. Storage. Source, where it actually is, which is in regional storage. Now the variables, prefix MVCC, and location is US2. Now, so far, this will get us to the same place we were before, which is we have a storage, and the storage is on the East US2. But now, the copy-pasting solution that we were talking about earlier, which is still not ideal, is actually much easier to implement, because now I could define two deployments, one in East, one in West, with very little amount of code. When we're going to do the next demo, which is related to the Azure virtual machine environment, which we're going to be moving on to soon, the amount of code we're actually going to be reducing within a module is going to be huge. So this gets us to two different build servers, storages. But if we wanted to actually have a third, so again, copy paste. But again, copy paste is never ideal. So my recommendation is to do something like this. So with the modules, you can actually do and let's change this again, utilize the for each. And in this scenario, let's just say to set, and let's give it 3 locations. So build this in West US2, and why not a third one in West US? And now for each iteration of this code, this is what's going to happen. The storage is going to vary with where it's going to be located. And I'm going to change the prefix. Let's keep it small though. I'm afraid of naming conventions in Azure, but that should work. So I'm going to go ahead and just execute this and see what it gets us. So if this works successfully, it should be adding 6 resources. Those 6 resources should be in different regions. So if I scroll up, let's see, one of those resource groups. So this one's going to be West US2, and as you can see, it has the right prefix assigned to it. There should be another one here for West US, and the final one for East US. Now, since Azure's being a little slow, I'm going to let this run. Actually, I can't say Azure's being slow. It's probably just the way I've been accessing through the portal. So let's see what we have here in resource groups. Those usually come across quickly. And storage accounts. Those will show up eventually. But I don't have to wait for those. Let me just move to the next demo because I don't want to run out of time too quickly. Let me go ahead and basically talk about reducing what we learned for Azure functionality. So I already have a lot of the code that I was going to use in this demo. And are you there? Oh, there they are. So good, demo worked. So let's go back to the Visual Studio Code. I'm not going to turn that down. Go to the Hello Azure VM. And this one, like the last demo, if we look at it, kill this. If we look at it, it's a huge file. And it has some additional stuff just because I added some locals to make it convenient to move code from one place to another. But I'm just going to reduce modules here to make my infrastructure work. If I run this, it's going to create a single VM out in Azure that is hosting Nginx. And one of the things that I mentioned that happens, like, let me run down the research quickly. So virtual network, stuff that is needed in order to create a VM in Azure. Virtual network, a subnet for that machine to reside. So those are my network requirements. Now, from the machine requirements, the machine doesn't necessarily need a public IP, but we are going to assign one to the machine. So it needs a public IP. It needs a network interface, so a network card that's assigned to that public IP and also to the internal network, the subnet. And then we need the virtual machine. And that virtual machine, in this scenario, uses the same SSH key as in my machine. This is probably not optimal. Again, this is demo code. Optimal would be to follow Microsoft's recommendations to actually store the SSH keys in Azure Key Vault. And there's actually, it's pretty easy to configure and very easy to your developers or IT group to actually consume those keys again. Now, the source image, it's Ubuntu 16.04. The disk, standard LRS. And the last thing that I want you to notice, because we haven't really touched on it, is provisioner. So here we're basically saying remote exec. So we're executing code remotely using this connection, which is connecting to the host, using the user that's defined on the top, AC admin, using the private key that's on my machine. And we're basically installing Nginx. But again, if I execute this, it creates one machine, which is fine. But what if I want to create 3 or 4 web servers? What if this was part of my scaling strategy when I'm building out environments for a specific need? So if that is the case, then I should probably refactor this into modules. And the correct way to do that, like I split the resources before, let's call one virtual networks. Create a main.tf. Now in that main.tf file, what I'm going to do is bring over everything that we need for the virtual network to be created, which in this scenario, it's the virtual network itself and the subnet. So I need variables here. I'm just going to copy this guy up to that folder. Now I have location and prefix, but I don't know if you noticed there's another one here called resource group name. That's because the resource group is created on the main TF that's on the root. So I'm just going to go ahead and create a variable for that. So I'll just expand here. Got that there. So I want to say this should work. I'm going to though execute it as a single unit, so I'm going to keep going. The next one would be building another folder for another module. And let's call that folder web servers. And on that folder, let's go back to my main.tm. I'm going to copy everything that I have all the way to the end, which is virtual machine related. So main.tf, there goes everything. Let me double check. Local resource group name, this is correct. So I believe that I can do just this, which is copy the variables here. Oops, come on. There we go. But there is one additional variable, if the subnet ID, which I actually should make present. So let's call this bar subnet ID. And here, let's just create an additional one, subnet ID. And there. So one quick glance over, Victor Network subnet, resource group, subnet ID, subnet ID. Yeah, everything looks like it should work. So back to the main.tf. Now here we're just creating a resource group. And now we've created modules that simplify the work of building out this environment full of web servers. So what do I need to do here? Let's use a web server. Let's call this is2s2. And source, it is from web servers. Now all the variables that we've come to see everywhere, prefix, location, and I believe that subnet ID is the other variable that should be here, but I'm going to hold on that one for a sec. And resource group name. And this one's going to be actually this resource group that we built, this resource group, which name it has RG. And what do we need? The name of that group. Now I did this a bit out of order because I should have built the virtual network before I built the machine. So I'm going back to the top, say virtual networks. Now, as before, let's copy this 3 guys. And this doesn't need anything additional to that. This just needs the prefix, location, and the resource. But one thing, and this goes back to when I was talking about variables, you look at my main file, there's an output variable here all the way on the bottom that's called subnet ID. And this variable basically exposes the subnet ID that was built. You may want to say it's encapsulating that. So going back to here, this should be module, virtual network, and sure, let's subnet ID. Now, the variables in this scenario don't really make much sense, just because, again, the way I designed them don't really fit a scenario where we're going to deploy multiple servers. But if we wanted to do that, well, let's keep location, because everything needs to be in the same location. But let's do a interpolation here, and let's say let's give it the prefix, and let's add a. I'm afraid of numbers, but hey, we'll find out if they work. So if I wanted a second server, again, another module. And this is going to be, I guess, 02, 01. And there. We also could have done this using the for each. I mean, I just did this for simplicity. But let's go ahead and test this. Let's see. Let me bring up a terminal.
Hey, Roberto, just want to chime in and say we got like 5 minutes.
All right. We'll get this probably in time. So going ahead and building that environment should fail quickly if there's anything wrong. I don't doubt that for a second that there is, but while this is building, in case because it is going to take some time, let me go back to my slides. And I just want to mention really the state, because at this point I've been looking at the state as local to my machine, and that's obviously not optimal. In most built environments, the state, and it actually is working here. The state, you want to keep it independently. So if you look at Microsoft's recommendation on that topic, let's see, I'm on a page, Azure Rm State. So Microsoft recommends us saving the information in Azure storage. So every time a build runs on a build server anywhere in the internet, they just have to download information from that Azure storage to see what is the state of your current infrastructure and modify it. So how do you do that? It's basically a configuration work. So a lot of it is here. There's a bash script that they provide. There's the way to get it into a environment variable, and there's the way you configure the Terraform environment to do it. So I'm not really going to do that for you guys, but I'm going to show you the code that's already here. That if you look at the last sample, the one for the remote state, you'll see that I have on my additional config file, which basically creates a resource group out in Azure, and in that resource group creates an Azure storage and a container. We don't have that, and we probably don't have the time to create it right now. But all that information, so it is on my environment file, TF resource group name, TF storage account name, and container name, are actually used in my build during my initialization phase. What I say, my backend is actually on Azure, on that resource group, is on that storage account that was specified in my environment, and using that container name. Now, all this, if you look at the provider configuration here, just saying that the backend is Azure RM makes it all possible. So there's a lot of convention there and configuration to make things work, but it works like a charm. And again, the goal to having your estate independent from the information that you're actually running, so your build servers, is to be able to keep your environment safe. Your state is your most valuable asset. So let me look at Azure real quick. A lot of things probably happen if I look at virtual machines. And there we have at least one of the virtual machines. And let's see what's in there. So I'm going to copy this because I just want to run it just to make sure that it behaved as expected. And there it is. So we were able to deploy an Nginx server out to the cloud with no problems. The other resource, well, it says here, let's see. Oh, I actually just deployed one. Let's see. Yeah, let's go with never mind. Apparently, I just deployed one. But I guess that's it from the point of view of my presentation. Again, on the last minute, so nailing it really fast. This is the end. And all I want to say is if you have any questions, I'm going to be hanging out in Discord a bit afterwards. And also all the information that you need is actually with the code. And I'm going to include the slides with that code. They're not very informative, but at least have a lot of references to resources that you can use to use Terraform in the future. So thank you very much. Thank you for attending this presentation. And hope you enjoy the rest of your day at CodeCamp.